Hello, my phenomenal viewers, and welcome on to this episode. So, on today's episode, we are going to be answering this PCHS Mock 2026, which corresponds to question 8C. So, the question reads: A motorist accelerates uniformly from rest and attains a velocity of 30 meters per second in 20 seconds. He then continues with this velocity for a further 20 seconds. He sees a child crossing the road 500 meters away and applies the brakes. This brings the car to rest after 15 seconds. The Roman one of the question says, sketch the velocity time graph for the motion. Then the Roman 2 says, show by calculation whether or not the motorist hits the child. So this question is under graphs of motion. So we've been given this information for us to draw the velocity time graph for this motion. So coming back to the question says that a motorist accelerates uniformly. So it shows that it contains uniform acceleration from rest. Whenever a body starts from rest, it simply means that the body started with a velocity of 0 meters per second. So the initial velocity of the body is 0 meters per second. So let us draw this graph together. Solution. So the question. So we have our velocity time graph. So this graph, the y-axis is usually the velocity axis. So the velocity which is in meters per second, then the x-axis is usually the time axis which is in seconds. So the question says that a motorist accelerates uniformly from rest. So this is the rest position, which is the origin. So since the body is accelerating uniformly from rest, it shows that the initial velocity is 0. So it started accelerating uniformly from rest up to when the velocity of the motorist becomes 30 meters per second. So at this point, let us consider that this is the velocity of 30 meters per second. And the time taken to arrive at this velocity is given in the question to be 20 seconds. So it takes this motorist 20 seconds to accelerate from rest to attain a velocity of 30 meters per second. The question further says that he then continues with this velocity for a further 20 seconds. So it shows that the car was then moving with a constant velocity, which is 30 meters per second. So the velocity is constant. So whenever you see this slanted line like this, if it is positive, then it indicates a uniform acceleration. If it is negative, it indicates a uniform deceleration. Then when you see a straight horizontal line like this or a velocity time graph, it shows that the acceleration is 0, meaning that the body is moving with a constant velocity. So the time here is another 20 seconds. So remember, we already have a 20 here, so we need to add this 20 to this previous 20. That gives us 40. So remember, when we take 40 minus 20, it gives us the 20 seconds that the car has moved with this constant velocity of 30 meters per second. The question continues. He sees a child crossing the road 500 meters away and applies the brakes. This brings the car to rest after 15 seconds. So when the motorist applies the brakes, the car starts to decelerate. So we now have a slanted line like this with a negative slope indicating a deceleration. So when it touches the time axis, it shows that the velocity is now 0. So the car is brought back to rest. So on the time axis, the velocity is 0. So what is the time taken to bring the car back to rest? The question says 15 seconds. So you take 15 plus 40, that gives us 55. Remember, when you take 55 minus 40, it gives you the 15 seconds that it takes the car to lift from the velocity of 30 meters per second to 0 meters per second or back to rest. So this is the velocity time graph for this motion. Hope it is understood. So like I explained, a slanted line like this having a positive slope for a velocity time graph indicates a uniform acceleration. Then a straight horizontal line, that is a line that is parallel to the time axis, indicates constant velocity. Then a slanted line like this having a negative slope indicates uniform deceleration. So this is how you obtain the velocity time graph for this motion. So this is the A part of this question. We've sketched the velocity time graph. So this is the velocity time graph from rest to rest. Now the Roman 2 part of the question says, show that or show by calculation whether or not the motorist hit the child. So the question says, he sees a child crossing the road 500 meters away. So before the motorist applied his brakes, which is at this point, remember, the motorist applied the brakes at this point. Before the motorist applied the brakes, he saw a child who was crossing the road 500 meters away. So he applied the brakes to come to rest. Remember, for the motorist to not hit the car, for the motorist to not hit the child, then the distance that the motorist has to cover before coming to rest must be lesser than the distance that he saw the child before applying the brakes. So for us to know the distance that the motorist covered after applying the brakes, we simply calculate the area under this part of this graph. We are going to consider only this part because this is the distance that the motorist covered after applying the brakes when the motorist saw the child crossing the road 500 meters away. We're not going to consider about the entire graph, no. We're going to consider just this section because this is when the motorist saw the child crossing the road and then applied the brakes to bring the car from a speed of 30 meters per second to rest. So remember, for a velocity time graph, the area under a velocity time graph gives the distance covered or the distance traveled. So looking at this shape like this is a right angle triangle. This is a right angle triangle, and the height of this triangle is 30, while the base is what? 55 minus 40, that gives us what? 15. So remember that area is equal to distance. So this is the Roman 2. This is the Roman 1 of the question, the Roman 2. Area equals to distance covered. So the area, which is the distance covered, is half base times height. So the base is 15. Since we have 55 minus 40, the length, this length, or the distance from here to here, which is 55 minus 40, that gives us what? 15. Then the height is 30 minus 0, that gives us what? 30. So this distance d is equal to a half times base, which is what? 15, times height, which is what? 30. So this gives us 15 times 15, which is 225 meters. 225 meters. So this is the distance that the motorist covers after the motorist applies his brakes when he saw the child crossing the road 500 meters away. So like I said earlier, for this motorist not to hit the child, the distance that the motorist should cover should be lesser than the distance that he saw the child when he applied the brakes while crossing the road. So the distance that the motorist saw the child away from him before applying the brakes is what? 500 meters. But after the motorist applied his brakes, the distance that he covered before coming to rest is what? 225 meters. So since d is lesser than 500 meters, it shows that the motorist did not hit the child. Had it been that the d is greater than 500 meters or at least 500 meters, then it shows that the motorist hit the child. So this implies since D is lesser than 500 meters, this implies the motorist did not hit the child. The motorist did not hit the child. So this is how you answer this question. Whenever you have a graph of motion, this is how you go about drawing that graph for a particular motion. So if you liked this video, please help me and share so that I can get to many students as possible. And if this is your first time coming across any of my videos, please do not hesitate to either subscribe or follow me so that whenever I upload videos like this one, you will be notified. And thank you for watching. Stay blessed.